The first time you run the query, by default, the database is not going to use the materialized view because the database is not going to use those constraints because the database is in a mode where data integrity, data consistency is enforced by the optimizer at all costs. There's a parameter, session level or system level query rewrite integrity. By default, it is set to enforced, meaning the database will only use constraints that it has personally validated. So here we do the full scan of the employee table, we add them up, and we find that there's 15 people that work in our company. We put the database into trust me mode. You can do this again at the system level in your reporting system or session by session. We run the same count, but notice this time it's a materialized view rewrite. But also notice that the answer changed. It used to be 15, now it's 14. The moral of this story is if you lie to the database is going to lie right back to you, okay? You put in place a bunch of constraints you said are true, but the data doesn't really support it. You might be really surprised in your data warehouse if you were to throw these constraints on. You think they should be all validated, but you run it against your data, and you might be surprised to find out how dirty your data actually is. A lot of your ETL processes, the things that cleanse the data, scrub the data, contain errors. And by not having the constraints on, you never know it. And you end up getting wrong, misleading information out of your data warehouse reporting system. But this does give you a way to tell us about this metadata without impacting your load performance and giving the optimizer more opportunities to optimize queries. There's another object out there, especially important in warehouse reporting systems. It's a thing called a dimension. So this is not like Buckaroo Banzai from the 8th dimension or anything else like that, an old movie, a favorite one of mine. This is a piece of metadata. It's just like a constraint. In fact, I stole my slide about constraints and I did a global change of constraint to dimension. They're facts, they give us information, they give this information to the optimizer. The presence of dimensions open up access paths that would not otherwise be available. The more metadata we can put into the data dictionary, the better. So what is a dimension? Dimensions describe to Oracle how to roll up data. By rolling up data, I mean we're describing to it relationships between various columns in our dimension tables in a data warehouse. Let's say you had sales information. In this table, you probably have a column called sales date or something similar, and you probably have a dimension table outside of that table that has that sales date column. They must be trying to tell me that I'm speaking too slowly or something, turning on the lights. Keep people, oh, it's getting warm in here. This is to keep you all awake. Good. You have this dimension table, has the sales date in it, and it might have another column that is the sales month. And the sales date is used to infer the month, and then the month is used to infer the quarter, and then the quarter is used to infer the year. So there's a hierarchy in this dimension table. You know it and I know it, but the database isn't aware of it. That's what the dimension object is about. I can describe these hierarchies to the optimizer. So a quick example, I'm going to create some sales data. I'm going to create about a year's worth of information for about 100 different customers with random sales amount. I'm going to create about 350,000 records. So I go ahead and I generate this data set and I gather statistics on it. This is my fact table. I'm going to create a dimension table. This is one of those type 2 slowly changing dimension sort of tables out there. But it's a dimension table that I'm going to join back to my fact table. And my rules for this table are, I'm going to take the transaction date, which is my order date for my sales table, and I'm going to store distinct values of that, as well as the month that that transaction date points to, as well as the fiscal year quarter. This is just a function to take a date and turn it into Oracle's fiscal year quarter. Your function would be different. That's why we have these dimension tables, because as you can see, it's not a trivial operation to turn a date into a fiscal year quarter. So we don't want to keep doing this over and over and over again. We store this implied information in a dimension table. I also can generate the fiscal year, the calendar year quarter, and the calendar year. So I store this information in this dimension table. So I gather statistics on my dimension. I add in all of my metadata. Here's my constraint that tells me that the primary key of that table is the day column that I put in there. I add a foreign key from my fact table back to my dimension table, and I tell the database that the sales table transaction date column is not nullable. So I've asserted all of these constraints. Then I create a materialized view. Materialized view is a lot like the index of your data warehouse. If you're doing a data warehouse, you're probably making heavy use of these to reduce query response times. But in this view, materialized view, I'll have the customer ID, the summation of how much I sold to that customer by month. My month-year column is the date rolled up to the month level. So I have to take the sales data, join it to the time hierarchy, my dimension, and then I'm aggregating it. And basically, I'm taking the 30 or 31 records I have for a customer by month, and I'm turning them into one. So this materialized view is approximately 1/30th the size of the original fact table. Querying this table will be a lot faster than having to join the large fact table to the dimension table. Gather statistics on that. Now, if I ask the question, give me the information, the sales amount information for a given month year. So I'm actually asking for this information summed over the individual customer IDs. So I don't want it by customer and month year. I just want it by month year. The optimizer looks at this, looks at the materialized view we just created, looks at the constraints we have in place, and says, I can use that materialized view instead of doing a join. So I'm not going to touch the two tables you actually queried. I'm going to query a third table and return the results based on that. We ask a very similar question. I would like that information, but not at the monthly level, but at the calendar year quarter level. Now, the optimizer doesn't know the relationship between the month-year column and the calendar year quarter. It doesn't know that it can infer the calendar year quarter from the month column. So in this case, it thinks it has to hit the sales table and the time hierarchy table, do the join, and return the answer. We've just queried 30 times the volume of data because the materialized view is 1/30th the size. So we add a dimension, and here's the dimension. We describe what attributes we're interested in, and we tell the database that day is the child of month year. So day implies month year implies calendar year quarter implies calendar year. Additionally, day implies month year implies fiscal year quarter implies fiscal year. By asserting that and telling the database to trust us, we're setting up this relationship, this hierarchy. We have to make sure our data actually matches what we've just described. So the database has to trust us. We rerun the same query, and look, all of a sudden, it's doing a materialized view rewrite against the materialized view and joining that to the time hierarchy. So it's taking this month-year summarized data, joining it back to the time hierarchy to get the calendar year quarter, aggregating that result, and giving us the answer in a fraction of the time. Further, if I ask for something rolled up to the fiscal year, it knows it can do the same thing. It goes back to the materialized view because it knows the materialized view built on month year, which implies fiscal year quarter, which implies fiscal year, can be used to derive this result.